Okay, so section 2.2, we're going to look at a couple different graphs that we can use to display our data once we have it in table form. So we're going to look at the histogram, a frequency polygon, and an ogive. So we'll see an example of each one of those. So the first one is a histogram. So this is where you display data using vertical bars of various heights to represent the frequencies of the classes. So you can see here in example 3 what a histogram typically looks like. So you have your x-axis, y-axis all labeled appropriately, and then the heights of the bars are just going to go up to whatever the frequency is for that set of values. So I think the most important thing for these 3 graphs is to be able to distinguish what values go on the x-axis. So for a histogram, it's going to be your class boundaries. So this is the table from the previous example. So we already figured out all of those class boundaries and the frequencies. So you would just take all of those class boundaries, put them on your x-axis, and then from there it should be easy to draw in the rest of this histogram. So I have this one here done for us. Do you have any questions on how a histogram works?
No, I'm doing well, but I have some background noise, so I'm muted at the moment.
Okay. All right, so a histogram, it's usually straightforward for students, so hopefully you don't have any questions on that. The next one is a frequency polygon. So a frequency polygon is where you use lines that connect points plotted for the frequencies at the midpoints of the classes. Okay, so we're still using that same data set from the previous example. And you can see over here what the frequency polygon would look like for this data set. So what goes on the x-axis is going to be the midpoints. So Dr. Insko, I'm going to ask you, because we didn't actually figure out these midpoints yet. So we had the class boundaries and we had the frequencies. How do you find those midpoints?
So isn't that where you take 99.5 plus 104.5 and then divide by 2?
Yes. So in order to do this frequency polygon, you would first have to go through and find all of those midpoints. And like he just said, you just add the 2 boundaries and then divide by 2. And that's going to give you your middle value. So you do that for all of them. You can also just recognize the pattern. Once you have 2 of them, they go by 5s. So you can just keep adding 5 as you go down. So you'll put all of those values on your x-axis, and then you're going to put a point for like 102, it's a frequency of 3, so you get a point there. 107 was a frequency of 8, so you put a point there, and so on. Now, what did I put over here?
That's the calculation of the midpoint?
Yeah, I showed my work. Okay.
Cool.
So we talked about that. Okay, now frequency polygon does have the characteristic that you do have to touch the x-axis on both sides of your graph. So that means you're going to have to go like back a step on each side. So if this value is 102 and this value is 107, logically, can you figure out which one that has to be?
98?
Yeah, so
90,
wait.
Oh no, 97, because you have to go back 5, right?
Yeah, so you're going by 5, so you would subtract 5 from 102, and that's going to give you 97. So on connect, you will have to figure out, what that value is, and then you will have to draw your graph and connect it, touching 97 on the x-axis. And then same thing on the other side. So if it's going 127, 132, then that one is 137. Yep. So frequency polygons, they're very straightforward. It's just usually students forget to connect it to the x-axis on both sides, and that's why they'll get it wrong. So you just have to try to remember that. Any questions on that?
No, it's great.
And then there's one other graph, and it's called an ogive. And it's used whenever you want to represent the cumulative frequencies for the classes. Okay, so we talked about the cumulative frequency distributions. That's just where the sum of the frequencies accumulated up to the upper boundary of a class in the distribution. So this was that table that Dr. Insko talked about on a previous page. So we already figured out how you determine this table. And then here's the ogive for it. So basically all of those values from your table are going to go on the x-axis. And then you're just going to plot a point at each one of the cumulative frequencies. So you have a point at 0. So your first value should always be directly on the x-axis, and that's because that first value in your table is always going to be 0. So it'll always touch on that side, and then it's just going to kind of grow as you go. So the next one was 2, then it goes to 10, 28, 41, and so on. Okay, so it keeps getting higher as you go. And then you'll notice that we do end at a frequency that matches our n value for that data set. And that's pretty much it for the ogive and all those graphs.
You know, if you've been looking at the COVID-19 data, they usually show like the bell curve and the ogive curve to show like total number of cases since, 2019 and so on.
Yeah.
I never knew what it was called before, so that's great.
Yeah, and it kind of shows you like basically like the slope for how quickly it's increasing. Mm-hmm. How many cases are being added, each day or whatever.
Okay, so now we're going to talk about the different shapes that your data can take, or different distribution shapes your histograms can take. So the first is the bell shape, or that's called the normal distribution. And this is the one you're probably going to be working with the most. This typically shows up when you're doing a randomly selected sample. And so that's typically what you're expecting to see. A lot of times when we look at test data, we expect to see a bell-shaped curve for a class. And some of these other ones will maybe think that something's up if we get a different shaped curve. Either the test wasn't very well written or something fishy is going on. The second one is uniform. And so that's where every class has about the same shape, and so, or the same height. And so that would be something where maybe if after you've curved, either you could try to make it uniform if you wanted to have the same number of people having the same grades going across. But that's not one you're going to use a whole lot. C is what's called right skewed. And so what that means is that most of the data is to the left of the peak or of the middle. And that's because the tail is skewed to the right. So you might think of that being backwards, but the idea is that the tail, or most of the classes, are to the right of the graph, whereas most of the data points sit on the left side. Left skewed, we might as well just say, is then the exact opposite. Everything is to the right. Most of the data is to the right. So the tail of your data is to the left. That long skinny piece of classes that are not very populated are on the left side. So that's why it's left skewed. And then we have J-shaped and reverse J-shaped. J-shaped just means that it's growing up, and that's kind of like that exponential growth you might see. And reverse shaped is the exact opposite, where it's sloping down. It has kind of that curve shape to it. And finally, we have bimodal, which means 2 peaks or 2 modes, and then U-shaped. And we won't really see these much, although I will say that you do see these sometimes when you write exams. You sometimes get bimodal test scores, and that's typically because you ask maybe 1 or 2 questions that are kind of confusing, and so either everyone gets it or everyone doesn't get it, and there's no middle ground. And so you get like a whole bunch of grades that are like A's, and a whole bunch of grades that are like C's, but not a lot of B's, because that middle ground, either you didn't cover it very well, or the question was kind of vague or something. And the same is true for U-shaped, you just wouldn't have those tails. But again, we won't be using that often in this class. It's just good to know that these things, if you see them, you can probably guess that your sampling was off. If you're trying to do a random sample, you should get a bell-shaped curve. And if you get bimodal or U-shaped, something might be fishy. Anything else, Karen?